we're looking at today in this video is break-even points. This has applications in business and manufacturing, which is what we're looking at in this example. So a company manufactures cables and sells them for $2 each. It costs 50 cents to produce each cable, and the company has fixed costs of $1,500 per week. Now the fixed costs are things that will remain the same no matter how many cables are produced. So for example, the rental of a building where they are manufactured would still remain the same whether 0 cables are manufactured or whether 500 cables are manufactured. That will not change, and so that is a fixed cost. Whereas the product or the plastic that goes into each cable amounts to 50 cents per cable. The first thing that we are asked to do is to find the equation for the revenue on X cables per week. And then the second thing we're asked to do is find the equation for the cost of manufacturing those cables each week. That will allow us to find where the break-even point is, or where revenue and cost is equal. So this break-even point is where we are neither making money nor losing money. We then are asked to find what the profit is if we were to manufacture 1,450 cables. And of course, where there can be profit, there can be loss. So we're asked to find how much money is lost if only 873 cables were manufactured. Here we're asked to find the equation for the revenue on X cables per week. So this is how much money we make from the sales of the cables. It's a linear equation or a straight line equation. And what we have is we get y equals 2x, because all we are doing is multiplying the number of cables by the amount for which we are selling them. And because we're selling them at $2 each, that gives us 2x. If we were to graph that, this is what the equation looks like. Part B, we're asked to find the equation for the cost of manufacturing X cables per week. Again, it's a linear equation, it's a straight line equation. And what we get is y equals 0.5x plus 1,500. Where each of those figures comes from is the 0.5 is equivalent to 50 cents for each cable. It's just been put into dollar values. So 0.5 is half a dollar, which is 50 cents. And then we've added the fixed costs. So that gives us 0.5 plus 1,500. That graph looks like this. And you can see when 0 cables are produced, the start value is 1,500 because we have that cost that does not change. Next, we need to find the break-even point, so where revenue is equal to cost. That is a simultaneous equation. So our first equation where we have the revenue of y equals 2x, we have our second equation of y equals 0.5x plus 1,500. We're going to solve this simultaneously. In order to eliminate the y value, I'm going to subtract equation 2 from equation 1. So you can see here, y take away y will give us 0. That eliminates that second variable. 2x take away 0.5x gives us 1.5x. Now there is no constant in the first equation for revenue. So we're taking away 1,500, which gives us negative 1,500. I'm then going to add 1,500 to both sides of the equation, which will give me 1,500 is equal to 1.5x, or 1,000 is equal to x. We want to identify what that x value stands for. And that x value is the break-even point of 1,000 cables. So if we manufacture 1,000 cables, we neither make a profit nor do we lose money. If we have a look at that on the graph, it is the intersection of the cost and the revenue, so where the two lines cross. We can double check this by substituting 1,000 into both equations. So we can see that by substituting 1,000 into the cost equation, we get 2,000, which is $2,000. We substitute 1,000 into the revenue equation, again, we get $2,000. So the revenue is equal to the cost, which equals $2,000. So the break-even point is 1,000, 2,000, or where 1,000 cables are sold. So now we're asked to find the profit on 1,450 cables. So the revenue on 1,450 cables, using our y equals 2x, will give us 2 times 1,450 or $2,900. Our cost on 1,450 cables, so again we're going to substitute the 1,450, so we get 0.5 times 1,450 plus 1,500 to give us 2,225. So the costs are $2,225. Now the profit is revenue minus costs. So if we take the revenue of $2,900 and we subtract a cost of $2,225, we have a profit of $675. Now if we are to look at that on the graph, we are looking at the difference between the revenue and the costs. So here you can see that the revenue is higher than the costs. So this difference between the two graphs is our profit. Now we're asked to find the loss on 873 cables. Again, we find the revenue. So substituting 873 into y equals 2x, we get 2 times 873, which gives us 1,746. So the revenue is $1,746. Our costs, we get 0.5 times 873, because we're looking at the costs on 873 cables. We then add our 1,500, which will give us $1,936.50. So our costs therefore are $1,936.50. Again, we use profit equals revenue minus costs. So our revenue of 1,746, take away our cost of $1,936.50, gives us a negative value of $190.50. This is a loss of $190.50. If we look at that in the graph, the costs are higher than the revenue, and the difference there is what is our loss. I hope you found this video helpful.